All right, here we are again. We're still continuing on with our math ACT school-wide learning. So far we've covered pre-algebra, we've covered elementary algebra, and now we're on to our intermediate algebra piece. So the intermediate algebra part on the math ACT is going to have 9 different questions. So intermediate algebra is going to be more like your Algebra 2 class. So things that you learn there might be things that you might see on that. So for right now, if you're a freshman or you're a sophomore and you haven't had Algebra 2, just pay attention to this. This might give you a little bit of information to allow you to try to tackle some of these questions this week. So some of the things that you're going to see on intermediate algebra are going to be topics such as quadratic equations, solving systems of equations, functions, matrices, and logarithms. So for the first part, quadratic equations, now in your Algebra 1 and Algebra 2 classes, you're going to cover a variety of ways that you can solve quadratic equations. Things like graphing, factoring, completing the square, and then probably everybody's favorite, the quadratic formula. So you do need to know what the quadratic formula is if you're going to use that. It's going to be, you always want to have it of the form ax squared plus bx plus c equals 0. So remember, when you use that, it has to equal 0 on one side. And then your quadratic formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you know what your a, b, and c values are, you just plug it in and you go ahead and you simplify that problem. Now, the only drawback on the quadratic formula is that it's pretty time consuming. So you might also want to make sure you know how to factor, or maybe you know how to solve by graphing if you're looking for a quick approach on the ACT. There is an example here, 3x squared minus 12x plus 5 equals 0. In this case, your a would be 3, your b would be negative 12, and your c is 5. And you can see how we take those values, we substitute them into the quadratic formula, and we very, very carefully simplify the expression to get 2 answers. That plus or minus tells us that we're going to do the equation with plus, and then we do the equation again with minus, and we can get our 2 solutions. Now, quadratic equations, like I said, can also be solved by factoring. So a couple of examples on how to factor. We still have a quadratic equation, for example, x squared minus x minus 6, and we want to make it equal 0 as well. And then we factor where we think about what are factors of negative 6 that add up to negative 1. And in this case, the factors of negative 6 that add up to negative 1 are going to be negative 3 and positive 2. So we write it as x minus 3 and x plus 2. Then we take the 2 factors, set them equal to 0, and we find out that the 2 roots are going to be 3 and negative 2. Now, factoring, we also can use this on an equation like 2x squared minus 3 equals negative 5x. This is a case where we've got to get everything to one side of the equation, make it equal 0. Now here, your teachers might have taught you several methods on how to factor something that's x squared, but we have a number in front. There's guess and check, there's the AC method, there's slide and divide. I think there's a bottoms up as another method. Whatever method you know how to use, this is one that you would want to factor. So you can't just say what are factors of negative 3 that add up to 5, because we've got that 2 out front. So using guess and check, we got 2x minus 1 and x plus 3, which then allows us to find our other factors, or our other roots in that equation. Another topic that we might see, systems of equations. Now, back in Algebra 1, and even in Algebra 2 some, you're going to solve systems using 3 different methods: by graphing, by substitution, and by elimination. Now, when we're talking about the ACT, we want to solve these as fast as we can. So maybe graphing's the fastest way. If you've got a graphing calculator, you can always graph the 2 equations, find your intersection point, and that's what we're looking for. Now, substitution, that's one where you solve one equation for one variable and you plug it into the other equation. It can be a little time consuming though. Elimination, same thing. In this case though, we're trying to go ahead and add our 2 equations so that one of our variables will cancel out. So we need to have a positive coefficient for one and a negative coefficient for the other, and then we're able to solve for x or solve for y and then plug in to find the other value. But again, on the ACT, whatever is the fastest, that's the approach you'd want to use. Now, functions, these are some things that you might look at in Algebra 1 and your Algebra 2 class as well. Functions are going to be where your x values are always different. So for every x value, we're going to have one y value to go with it. Now, one way to test for that is to use the vertical line test. So as you can see, we've got a couple examples of things that are functions and things that are not. Lines, for the most part, are going to be functions, but we're looking for it to not touch that vertical line in 2 places. Like a circle. On a circle, the vertical line is going to touch twice. Or maybe on a sideways parabola, it's going to touch twice. So that tells us that that x value has two y values. So that's why it's not a function. Now, and one thing that you're going to see quite a bit on the ACT is using something called function notation, where it gives you something like f of x equals 2x plus 5, and then they say find the value of f of 5. That just means take 5 and plug in for x. So in this case, it becomes 2 times 5 plus 5, and you get your value of 15. Now that represents an ordered pair on our graph, which would be 5, 15. And then finally, we have composition of functions, where maybe we have two different functions, f of x and g of x. And they're going to ask you to take g of x and substitute into f of x, and we get that composition there. And the last thing that we see on the intermediate algebra part would be logarithms. A lot of times logarithms, they're going to ask you to solve a log equation, and it's going to be helpful to know how to convert between logarithmic form and exponential form. So this is, in this case, where we have log base 2 of 4x plus 1 equals 5. To convert this to exponential form, we take the base of the log, which in this case would be 2, and we raise it to the 5th power, and we make it equal 4x plus 1. So knowing that conversion would help you. Sometimes you can even take the values if you don't know how to do this. The nice thing on the ACT on a question like this is use your answer choices. If it's a question you're not sure how to do, use what's given and plug that back in. In this problem, you could take your answer choices, plug it in for x, and see which one gives you 5. So don't be afraid when you see a problem like this on the ACT that if you don't remember that content or maybe you haven't covered that content, use what you're given and see if you can figure it out from there.